Hello everyone, this is the lecture for section 4.5, logarithmic properties. So the first two sections of chapter 4, we're just learning about exponential functions, right? 4.3, 4.4, we learned about what a logarithm is and how to graph them, right? 4.5 deals with logarithmic properties. And these logarithmic properties, they match up to the exponential properties, more or less. They match up to those exponential properties that we saw in section 4.1. Okay, that's basically this whole entire section. We're going to learn the logarithmic properties that go with logarithms, right? Okay, so to start, I need to show you guys both of these, this one and that one, okay? Whenever you have something like this, 0. Whenever you have something that looks like this, 1, okay? Just keep an eye out in this one, right? The b that's inside the log, right? And the base of that logarithm have to be equivalent, right? Okay? Next one, okay, are these two. Okay, these are called sort of like the inverse properties or the cancellation properties of logarithms. Both of these are going to be equal to just good old x. Whatever that x value is, it just becomes x. Okay, and the reason why we call it the inverse or the cancellation properties is because you see that log base b of b to the x, that's the thing that cancels. Same thing here, that thing cancels there. Okay, basically both those b's have to be the same, okay, in order for the log and the exponential to cancel each other out. Okay, I forgot to mention, I'm going to put this up here, a to the b is equal to c, the thing that I've been saying sort of on a regular basis now, right? This is our boomstick when we talk about anything between logarithms. Log base a of c is equal to b. Whenever we talk about converting exponentials to logs and logs to exponents, right, this is the thing that I'm referring to, right? I've been referring to this as a boomstick in class, right? All of the things that I'm going to cover today, right, and all the things about logarithmic properties that you'll ever see, right, can be traced back to a proof using that thing in the pink right there. Okay. Am I going to show you the proofs? Nah. If you ever do need to know them, I'll let your subjects figure that out, right? For now, just know that this is where they're coming from. Okay. All right. Let's keep going now. Okay. The next two, product rule and the quotient rule. Okay. For the product rule, suppose you had two things that are being multiplied together. So there's a multiplication between there, right? Okay. Then this is equivalent to log base b of m plus log base b of n. Essentially saying we can split these up, the multiplication up inside a logarithm as the sum or the addition of two logarithms. Okay? And likewise, right, if you have the division, hopefully you guys can see where this one's going, right? Log base b of m minus log base b of n. Okay, and these more or less, actually exactly, match up to this. If you guys remember, if you had a to the n times a to the m, what we got to do is just do a to the n plus m. We were able to add the exponents, right? And then over here, if you recall, right, a to the n divided by a to the m, that was a to the n minus m. We got to subtract them, right? So these two statements, this one and this one, right, come from a direct proof that involve these two. Okay? Awesome stuff, right? So now, how the heck do we use these? Okay, you use them how exactly how you think you do, right? There is multiple ways for, I mean, so long as you're using them appropriately, right? And that's the hard part to figure out. you can do any one of them in any order you want, okay? So for example, right, let me take this first one right here, okay? Let me scroll up a little bit. There we go. Okay, so for example, for this first one, I can automatically take these two things as being separate, that and this, right? So then this is equivalent to log base 3 of 30x plus log base 3 of 3x plus 4. Okay, and then this one, okay, I can even separate that a little more, and I can say log base 3 of 30 plus log base 3 of xx plus log base 3 of 3x plus 4. And we are done. This is it. You can break this up some more, just like I did with exponents, right? Just like I did with exponents. I'm getting you all comfortable with very involved usages of all of these rules, right? But will you ever see something this wacko crazy? No, no. Okay. I'm sort of making you guys practice much harder things, knowing that you're going to see much easier things in real life, out in the real world. Okay. Now, the next one, right? Hopefully you guys see there's an 8 that I can separate away, and then there's the k, right? So I can say this is log base 8 of 8 plus log base 8 of k, right? Now, this probably comes, hopefully you guys are observing this, right? Log base 8 of 8, we have a rule for that. That becomes 1. Done. This is it. This is as far as I want to take it. Okay? All right. I've got some quick checks for you guys to try. Okay? Like I said, we'll do these in class. Next one up, power rule. Okay? So this one, suppose you had log base b of m to some power n. So this n that's up there is a power. Okay? Then what I can do is this. This is equivalent to n times log base b of m. Okay? And hopefully you guys see this, right? That this rule basically comes from this one, right? If you guys remember, if you have a to the b, right, to the c, sorry, actually I think I used a to the m to the n power, right? That is a to the m times n, okay? The way that a lot of people like to see it, you can grab that power and basically bring it up front as a multiplication. That's it. Okay, so for that, right, let's take these two, bam, and bam, let's just say we want to expand it a little more, right? This is equivalent to 5 times log base 2, whoops, log base 2 of x, right? And then this one, it is also 2 times the ln of x. We are done. That's it. Okay, like I said, just know that these exist for now. Okay. Okay, so now, expanding logarithmic functions. When you get into the harder sciences, when you get into the harder, the stuff that's really up there in chemistry and physics and math, sometimes you might need to break away some stuff inside of a logarithm, and stuff like that cancels out, right? Okay, that's what we're going to practice here. Okay, so suppose, for example, you had this, and I asked to write it as the sum or difference, right? I can break it up so hopefully you guys see that there's a top, right? There's a top part, and then there's a bottom part, okay? So I can go ahead and do, this is equal to, right, ln of x to the 4th times y, right, minus ln of 7. Okay, this thing right here, this portion right here, this has got a multiplication in between. We can break that up into addition, right? So this is equivalent to ln of x to the fourth plus ln of y minus ln of 7. Okay, and then this one in particular, right, that has an exponent in it. So I can bring down the exponent using my product rule, right? So this final answer for ln of x plus ln of y minus ln of 7 is as far as I want to take it. Bam, all done. Okay. It works with any type of log, right? So in the previous example, in example 4a, I was talking about a natural log, right? But the same rules work when you're talking about the common log or any other log for that matter, right? So then this is also equivalent to log of x squared y cubed minus log of z to the fourth. Okay, that first one I can expand some more. Okay, and actually I need more space. Move this out a little bit. There we go. So then this is also equivalent to log x cubed plus, whoops, let me close the parentheses first, right? Plus log, sorry, it's not cubed, squared, haha. Log y cubed minus log z fourth. Okay, now hopefully you guys see this. All of these have powers on them, right? So then the final answer, this is as far as when I want to take it, right, is going to be 2 times log x plus 3 times log of y minus 4 log c. We are done. This is as far as I want to take it. Okay. Sometimes we might need to, and this is now practice for your exponent rules, right? We can rewrite these things so that we can do stuff with the logarithm rules, okay? So if you guys remember, right, the rule here is this for the first one, right? The square root, let me actually write it a little closer together, right? The square root of x, that is equivalent to x to the 1/2 power, right? So then that means I can do log of the square root of x is equivalent to, it's equal to, log of x to the 1/2. And now I can use my power rule, right, for logarithms to bring out that 1/2. So this is now equivalent to 1/2 log of x. Okay, same thing can be said here, right? I'm going to put it over here on the right-hand side. The cube root of x squared, that is equivalent to x to the 2/3. So then ln of the cube root of x squared, that is equal to ln of x to the 2/3, 2/3 ln of x. We are done. That is it. Okay, like I said, sometimes you're gonna need to be able to use some of the exponent rules to rewrite some certain things so that you can use the logarithm rules to actually simplify stuff out. Okay, there's nothing wrong with it. Just this actually is a good practice for you to practice your rewriting of exponential stuff. Okay, so then next question, can we expand this? hopefully everybody's warning sirens going off, right? If I'm asking it, there's probably a problem with it. The answer is heck no, right? No. Okay. Up to now, there are no rules for breaking up an addition that's inside a logarithm. Does that make sense? So all of our rules, they turn stuff into an addition, right? But the stuff that's inside has to be multiplication, right? There are rules for, if you have something with a power, right? The power can come up front, right? But it has to be all by itself, right? It can't be added on to something else. So there are no rules for this, right? Okay, I gotta write that out, right? Before people start thinking that there is, or start confusing the rules that we have for something that can be used for something like this, right? So whenever you see something like this, the addition of something inside of a logarithm, right? We can't do anything with it. Okay. All right. Let's keep moving. Condensing logarithmic expressions. So now we got to condense stuff. So just like all the rules that I had given you guys, not maybe what, 10 minutes ago, right? Those same rules can be used in reverse. Okay? That's simple. The same rules can be used in reverse. Okay? So let me grab this, right? And I'm going to use all of my logarithm rules. I'm going to try to go backwards. I'm going to try to turn this into one single logarithm. Okay? So I'm going to write it out first, right? Actually, no. I think it's already there. We're good. We're good. We're good. I can group however I want, right? So long as I use my rules appropriately. So I'm going to grab these two, right? The rule states that if I have an addition of logarithms, right, I can combine them into one single log with a multiplication in between. So these two things can become this. Log of 3, 5 times 8. I'm going to leave it that way. I'm not going to touch it yet, right? Minus log base 3 of 2. Okay, so that log base 3 of 2, the minus of the log base 3 of 2, that's just coming along for the right. I haven't done anything with it yet. So that thing in the pink became this thing right here. That's the backwards of my logarithms, right? Okay. So now I'm going to go ahead and handle that negative log 3 of 2, right? If we have the subtraction of two things, right? If we have the subtraction of two things, I can grab the first one divided by the second one, right? So this can be reduced to log base 3 of 5 times 8 divided by 2. Okay, now I can do the math inside the parentheses and hopefully stuff sort of reduces, right? So this is equivalent to log base 3, 8 times 5, that's 40, divided by 2, equivalent to log base 3 of 20. We are done. One single log. Okay, now this is just with values. Same thing happens with expressions, right? So suppose we had this right here, right? Same stuff. I'm going to grab these two first. Okay, actually, no. I am going to grab, you guys see this? All of these have, those two have power. So I'm going to grab the power things and turn them back into exponents, right? So hopefully you guys remember, right? This is going to be equal to, right, log of x cubed, right, plus log, I'm going to do a double parentheses here, x plus 5 to the 4th minus log 2x plus 3. So that thing at the end is just coming along for the right. I'm not doing anything extra for now. Got it? Okay. So now, next thing now, these two. Actually, no. I want to do these two first to show you guys that I can do these in any order I want. So I'm going to grab these two Since it is a subtraction in between, I can turn this into a division, right? The first one minus, the first one divided by the second one, right? So then this is equivalent to, in this scenario, right? Log of x cubed just gets to come along for the ride, plus, okay, log, now I'm going to do my quotient rule, right? X plus 5 to the fourth divided by 2x plus, whoa, let me make it neater, huh? 2x plus 3, bam, and that is to the fourth, okay? And now I can use my product rule with the remaining two things, right? So this is going to actually also be equal to log x cubed times x plus 5 to the fourth over 2x plus 3. Double ding there. And we are done. This is as far as I want to take it. If you do it the other order, that is perfectly fine. You should get the same answer. Okay? All right. What comes up next is quick checks. Again, we'll do these in class, and I think it's lecture questions. Awesome. Okay. If you have any questions on the stuff that I just covered, ask me during lecture question, or sorry, ask me during quick check time, during class, or during my office hours. Okay. Besides that, happy studying.